Alright, so the blue line represents the airplane having no paper clips on it, and then the red line has the airplane having two paper clips, and the yellow having four, and the green having six. And by our data, with no paper clips, the plane goes further.
Our measured variable was height, and our three variables was standing on the ground, standing in a chair, and sitting in a chair, which are represented on the graph as blue, red, and yellow. We measured the distance the plane flew. That was measured in meters, and on the ground the numbers were pretty consistent, but standing on a chair and sitting in a chair, they were not consistent because there were several outliers.
Hello, I'm Ali Shalabi.
I'm Joshua Burke.
I will be doing A, standing on the ground variable.
I will be doing B, standing on a chair variable.
The farthest the standing on the ground variable went was 9 meters, and the smallest was 3 meters. As you can see, there is an increase in the meters. Trials 3 through 7 was really consistent.
The shortest distance was 4 meters, and the longest distance was 9 meters.
Wait.
The resulting pattern was very inconsistent.
Overall, standing on the ground variable succeeded more. That was our graph. Thanks for watching.
As you can see in plane A, it was consistent until trial 4 because it didn't go as far as it did before. But in trial 5, 6, it became consistent again. In plane B, it wasn't as consistent as plane A because we folded the wings and we lost total control. As you can see in trial 4, it becomes 3 times more, which lost control.
We had several anomalies where the plane would throw in a 360-degree spin, and we had no idea why.
Okay, so this is our paper airplane graph. The blue part is the first plane, and it did not have a consistent rate, and it was kind of floppy, so it didn't go as far as the other one.
On our second airplane, we added paper clips for more weight, and it was more successful. We added the paper clips to the back, which caused it to go higher and have more consistent flight. This shows that adding weight to the back improves flight.
Our title of the lab is Airplane Height Experiment, and we're experimenting if the height changes how far the plane flies. The y-axis represents the distance in meters, and the x-axis represents the 5 trials. The green line represents the plane thrown from a chair 42 centimeters high, while the blue line represents the plane thrown from the ground.
At the start of the trial, the results were more spread out. In the middle, the results became closer, and at the end, the results overlapped. We can conclude overall, thrown from higher, the plane gets more distance.
Our experiment was how does height affect the distance of a paper airplane. The 4 different heights we used were sitting down, kneeling, standing on a chair, and standing on the ground. As you can see, the variable we used was height.
We tested the plane 5 times from each height as shown on the x-axis. We measured the distance traveled in meters as shown on the y-axis.
We found that standing up had the highest average distance, which was 7.7 meters, and we found that sitting on the ground had the lowest average distance of 5 meters. From this, we conclude that the higher up you are, the farther your plane will fly. It's not pausing. Stop.
This is our average distance of plane graph where we're trying to test which height would make the airplane travel farther. The x-axis represents the height we threw the airplane at, and the y-axis represents the average distance traveled in centimeters. We took 4 tests for each height and averaged them.
At 103 centimeters, our test average was 519 centimeters. At 149 centimeters, it was 684. And at 184 centimeters, it was 345. Looking at the results, 149 centimeters traveled the furthest, then 103 centimeters, then 184 traveled the least. This was because the plane would hit the ceiling.
We tested paper airplane by adding paper clips to the center of the model to increase its weight. As you can see on our graph, the one that worked the best was the one we added only 2 paper clips. Unfortunately, it was the least consistent. On the other hand, the most consistent one was when we added 4 paper clips. Although it only, according to the whole graph, it went second farthest of the paper clip trial.
In conclusion, what we have found with this experiment is that a little bit of weight goes a long way as the plane reaches
longer distances than it did in the control trial, but too much weight drastically decreases the distance that the plane reaches.
So for our paper airplane data, we decided to do 3 trials. The first one was the control with 2 paper clips at the bottom. The second one had 3 paper clips, and the third one had 4 paper clips to increase the weight.
To understand our graph, you're first going to want to look at the control variable, which is the green. It's about average compared to the rest of it, but one less. So let's look when you add more weight. When you add more weight, it increases the distance. At 3, we increased it from 7 on average to 8, and then when 4 to 8 again. So we suggest adding more weight, but not too much weight.
Thank you.
We tested our paper airplane by adding paper clips to the center of the model to increase its weight. As you can see by our graph, the trial that worked the best was the one when we only added 2 paper clips to the paper airplane. Unfortunately, it was the least consistent. The one that was the most consistent was the one where we added 4 paper clips, although it did not go as far. But according to all the trials, it did go the second farthest.
In conclusion, what we have found with this experiment is that a little bit of weight goes a long way, as the plane reaches longer distances than it did in the control trial, but too much weight drastically decreases the distance that the plane reaches.
I'm Lily Moore.
And I'm NJ Huang.
And our experiment was planes and paper clips. We wanted to see if adding paper clips to a plane would affect the distance it's traveled because of the weight on it.
So for 0 paper clips, our plane went 6.4 meters. For 1 paper clip, our plane went 5.9 meters. For 2 paper clips, our plane went 4.7 meters. For 3 paper clips, our plane went 2.5, and for 4, it went 1.2. So in conclusion, the less weight on your plane, the farther it will travel.
We tested our paper airplane by adding paper clips to increase its weight. As you can see by our graph, the trial that worked the best was the one when we added only 2 paper clips to our model. Unfortunately, that was the least consistent trial. On the other hand, the most consistent trial was the one where we added 4 paper clips, and it did go higher than the other 2.
In conclusion, what we have found with this experiment is that a little bit of weight goes a long way as it reaches longer distances than the control, but too much weight drastically decreases the distance the plane reaches.
So this is our paper airplane lab, and let me just show you. I want bigger screen. We have this going on. We have this going. These are the 2 paper airplanes. I can go over here, and then they'll hit play, and we'll be taking over, and we'll talk about this big convection point over here. And then we'll say good.
As you can see, this is our graph for our paper airplane experiment. Our first attempt at throwing our paper airplane halfway through our release went 8 meters. Our second attempt went 7 meters. Our third and fourth attempt at throwing our paper airplane halfway through our release went 8 meters. Our final attempt went 9 meters.
In conclusion, throwing with more force worked better than throwing with half force.
Okay, this is the paper airplane graph, and we basically got a paper airplane and added weight to it. And the way we measured how much weight we added to it was by paper clips, so we would add 1 paper clip at a time.
And in conclusion, a plane with less weight flies further than a plane with more weight, and we had an inconsistency at the beginning due to imperfect controlled variables such as how strong we were throwing the airplane.
Hi, this is our paper airplane graph by Jack,
Tommy,
And Samantha.
the variable we are testing is weight. We did that by adding paper clips to our plane. We did 10 trials starting at 0 paper clips and added 1 paper clip after every 10 trials. As you can see, the plane with 2 paper clips went farther on average than the other planes.
In conclusion, balancing the weight around the plane gets you the best results.
This is a science check with Dylan Gieske.
And Lauren Wischel, and this is our paper airplane.
The manipulated variable used was weight, starting with 0 paper clips for the control, with an average of 4.7 meters for 5 throws.
Our experiment showed us that when you add paper clips to the airplane, the distance would be reduced each throw. For example, the average was 5 paper clips was 3.8 meters, then 3.45 meters with 10 paper clips, and 2.7 meters with 15 paper clips.
So in conclusion, the more weight we add to the paper airplane, the less distance it will travel.
In our paper airplane experiment, we were testing how the mass affected the distance the airplane went in the form of paper clips. Our first trial was the control, which had 2 paper clips at the bottom. Our second trial had 3 paper clips, and our third trial had 4 paper clips at the bottom to help increase the weight.
As you can see, the control group did fine, but when you add more mass at the bottom in the form of paper clips, it adds about 1 meter and 1.5 meters to the distance. But when you add too many, it plateaus the scores. So we would say adding some mass is good, but too much is bad.
Thank you.
We tested a paper airplane by adding paper clips to the center of the model to increase its weight. As you can see on our graph, the one that worked the best was the one we added only 2 paper clips. Unfortunately, it was the least consistent. On the other hand, the most consistent one was when we added 4 paper clips. Although it only, according to the whole graph, it went second farthest of the paper clip trial.
In conclusion, what we have found with this experiment is that a little bit of weight goes a long way as the plane reaches longer distances than it did in the control trial, but too much weight drastically decreases the distance that the plane reaches.
I'm Matthew Sprague.
I'm Giselle Bryant.
And for our paper airplane, we use paper clips as our variable, which is weight. So as you can see, we have 3 trials. One trial is number 1, and that's represented by the blue line. The other trial number 2 is the red line, and trial number 3 is represented by the yellow line. As you can see, trial 1 and 2 look pretty consistent on the graph. However, the trial 3, there is one major inconsistency in this point right here, which is probably because we threw it wrong, or we did not throw it how we've been throwing it.
From the data we collected, you can conclude that the less weight that's on the paper airplane, the farther it will go.
We want it to be bigger. I hope that wasn't my first word onto my recording. It may have been. And now I'll do this, and I'll go down here, put my little highlight on here as I'm talking about it. So we started off here with the bigger plane. You can see the smaller plane went further than the bigger plane pretty consistently until the very end. At the very end, they kind of crossed, but consistently my results were that a smaller plane will go farther than a big plane. And I think it's because the way we did it, the actual experiment that we did, we threw it harder. It was easier to throw. Done. 32 seconds.
In our paper airplane experiment, we had 3 planes: a regular plane, a plane with a shorter wing of 5 millimeters, and a plane with a shorter wing of 10 millimeters. As you can see, they all went the same amount, and they were pretty inconsistent. I think the best one would be the blue one because it was the most consistent and with the most high records.
Yeah.
Alright, so the blue line represents the airplane having no paper clips on it, and then the red line has the airplane having 2 paper clips, and the yellow having 4, and the green having 6. And by our data, with no paper clips, the plane goes further.
This is Andrew Messina's paper airplane project, and our question is, will the plane go
I'm Alondra Heckerstrand, and I did a paper airplane lab with paper clips as my variable. So it shows the 2 highest was the red one and the green one, but the green one had a larger slope and wasn't as consistent as the red. The yellow, on the other hand, was very consistent, but didn't go as far as the rest of it. So I would say if you were doing a paper airplane with paper clips and trying to make it go farther, I would either do with one back paper clip or with both paper clips in the middle and in the